Given the function f at x, find its inverse and then verify that they are truly inverses of each other. The first thing that needs to be done is that we need to replace f at x with y. This is important because the second step is going to be for us to switch the x and y variables. So we need to be able to see that y value in order to be able to switch the x's and the y's. Now to get the inverse relationship, that's when all y's become x's and all x's become y's, and this is now the inverse relationship. However, we do want to write this inverse relationship using functional notation. And in order to do that, we're going to need to solve for y in this inverse relationship. So we'll subtract 9 from both sides, and we'll have 4y cubed is equal to x minus 9. Let's divide both sides by 4 to get y cubed is equal to 1/4 x minus 9/4. And then we'll take the cubed root of both sides to completely solve for y. So on the left, we now have y, and on the right, we have the cubed root of 1/4 x minus 9/4. Now that we've got it completely solved for y, we can rewrite this using functional notation. This is the inverse function, so we'll need to use f inverse here. The original function is f, and so this function that we found is the inverse of that f. The last thing that we want to do is to verify that these two functions are indeed inverses of each other, and we do that by composing f with f inverse, or we could compose it the other direction, f inverse of f, but either way that composition should simplify down to being just x. And that is actually what we've been asked to do in the second part of this problem. So down here we'll complete the verify step. So we start by rewriting these two functions down, and then we will compose them, and I'm going to compose them in the direction where f is on the outside and our inverse function will be plugged into that. The inverse function is the cubed root of 1/4 x minus 9/4. And when we cube this cubed root, these operations essentially undo each other. So we'll end up with the 4 on the outside, and in the parens we now have 1/4 x minus 9/4, and then we still have our plus 9 off on the end. So again, this is f composed with f inverse. Now let's distribute the 4 into this parenthesis, which is going to yield 4 times 1/4 x, which is just x, and 4 times negative 9/4 is now going to be negative 9, and we still have the plus 9 on the end here. And we can see that the 9's now cancel, and this ultimately is going to simplify down to being just x, which is what we needed in order to verify that these two functions were inverses of each other. So we do have the correct inverse function.